Assalamu alaikum students. This is third lecture of maths, book 9 and for the students of class 8. Our topic is matrices and determinants, which is unit 1. Today we are going to do exercise 1.3. I want you to keep your books in front of you for better understanding. At the end of this lecture, you will be able to know about addition and subtraction of matrices, commutative and associative laws of addition of matrices, additive identity of a matrix, additive inverse of a matrix, symmetric matrix, and about skew symmetric matrix. Students, our first topic is addition of matrices. Let A and B be any two matrices with real number entries. The matrices A and B are conformable for addition if they have the same order. For example, this is matrix A and this is matrix B. The order of matrix A is 2 by 3 and the order of matrix B is also 2 by 3. As order of matrix A and B are same, so matrix A and B are conformable for addition. Addition will be obtained by adding the entries of the matrix A to the corresponding entries of the matrix B. This is how we add matrices. As you can see that A is written first, so I'll write matrix A first, then plus sign, and then matrix B. In this step, I'll add the entries of the matrix A to the corresponding entries of the matrix B. After addition, I'll get this matrix as 2 minus 2 is equal to 0. So here is required matrix. This is what the addition of matrices is. This is question number 1 of exercise 1.3. Which of the following matrices are conformable for addition? These matrices are given in your exercise. So to solve this question, you need to keep this condition in your mind that two matrices are conformable for addition if they have same order. I am doing one for you and do rest of the parts by yourself. Students, as you can see that order of matrix A is equal to order of matrix D, that is 2 by 2. So matrix A and D are conformable for addition. Next topic is additive inverse of a matrix. Additive inverse of any matrix is obtained by changing to negative of the symbols entries of each non-zero entry of the matrix. For example, this is matrix A and I'll multiply minus sign with each non-zero entry of the matrix A and I'll write it like this. As minus sign is written first, so I'll write minus sign first and then matrix A. Like this. After multiplying minus sign, I'll get this matrix and at the end I'll denote this matrix by B. To show that B is additive inverse of A as only sign of entries has changed. This is question number 2 of exercise 1.3, that is, find the additive inverse of the following matrices. Few matrices are given here. I hope you can do this question by yourself. Here is question number 3 of exercise 1.3. Matrices A, B, C and D are given. This question is having 9 parts and I am doing part 1 and part 7 for you. Here is its part 1. As you can see that A is written first, then plus sign and then another matrix. So by following the same sequence, I'll write matrix A first, then plus sign and then another matrix. In this step, I'll add the entries of first matrix to the corresponding entries of the second matrix. And after addition, I have got this required matrix. Students, here is part 7 of question number 3. As you can see that -2 is written first and then matrix C. So by following the same sequence, I'll write -2 first and then matrix C. That means I have to multiply -2 with each and every entry of matrix C, like this. After multiplication, I have got this matrix. Students, now do rest of the parts of this question by yourself. Next topic is subtraction of matrices. Let A and B be any two matrices with real number entries. The matrices A and B are conformable for subtraction if they have the same order. For example, this is matrix A and this is matrix B. The order of matrix A is 2 by 3 and the order of matrix B is also 2 by 3. As order of matrix A and B are same, so matrix A and B are conformable for subtraction. Subtraction will be obtained by subtracting the entries of the matrix A to the corresponding entries of the matrix B. As A is written first, so I'll write matrix A first, then minus sign and then matrix B. In this step, I'll subtract the entries of the matrix A to the corresponding entries of the matrix B. After subtraction, I have got this matrix. As 1 plus 1 is equal to 2, so here is the required matrix. Students, this is how we subtract two matrices. Okay students, now we are going to learn two laws here. Number 1 is commutative law under addition and number 2 is associative law under addition. Here is explanation of commutative law under addition. Let A and B are two matrices of the same order. Then A plus B is equal to B plus A is called commutative law under addition. Let this is matrix A and this is matrix B. And commutative law under addition is A plus B is equal to B plus A. As you can see that left hand side of this equation is A plus B and the right hand side of this equation is B plus A. On left hand side, A is written first, so I'll write matrix A first, then plus sign and then matrix B. And on right hand side, B is written first, so I'll write matrix B first, then plus sign and then matrix A. As the sequence of matrix A and B is different on both sides, but the answer of left hand side and the answer of right hand side should be equal. Now, by considering left hand side first, I'll add the entries of matrix A to the corresponding entries of the matrix B. And after addition, I have got this matrix. Now come to right hand side, and in this step on right hand side, I'll add the entries of matrix B to the corresponding entries of the matrix A, and after addition I have got this matrix. As you can see that left hand side is equal to right hand side. Thus the commutative law of addition of matrices is verified, that is A plus B is equal to B plus A. Now here is explanation of associative law under addition. If A, B and C are three matrices of the same order, then bracket starts A plus B brackets end plus C is equal to A plus bracket starts B plus C brackets end is called associative law under addition. Let this is matrix A, this is matrix B and this is matrix C. And here is associative law under addition. As you can see that this is left hand side of this equation and this is right hand side of this equation. On left hand side I'll write matrix A plus matrix B in brackets, then plus sign and then matrix C. And on right hand side I'll write matrix A, then plus sign and then bracket starts matrix B plus matrix C brackets end. You need to keep this thing in your mind, that the answer of left hand side should be equal to the answer of right hand side. Now I'll consider left hand side first. As we know that according to the rule we have to solve brackets first. So in this step I'll add the entries of matrix A to the corresponding entries of matrix B, then plus sign and then matrix C. Now after addition I have got this matrix, then plus sign and then matrix C. In this step again I'll add entries of first matrix to the corresponding entries of the second matrix, and after addition I have got this matrix. Now on right hand side I'll write matrix A first, then plus sign and then I'll add the entries of matrix B to the corresponding entries of matrix C. Now by following the same sequence I'll write matrix A first, then plus sign and then after addition of matrix B and C I'll get this matrix. Now again in this step I'll add the entries of first matrix to the corresponding entries of the second matrix, and after addition I have got this matrix. Now you can see that left hand side is equal to right hand side, hence the associative law under addition is verified. Our next topic is additive identity of a matrix. If A and O are two matrices of the same order and A plus O is equal to A and O plus A is also equal to A, then matrix O is called additive identity of matrix A. Let this is matrix A and this is matrix O. Here left hand side is A plus O and right hand side is O plus A. I'll consider left hand side first. As A is written first, so I'll write matrix A first, then plus sign, and then matrix O. In next step, I'll add the entries of matrix A to the corresponding entries of matrix O. And after addition, I have got this matrix. Here you can see that this obtained matrix is equal to A. Now consider right hand side. Here O is written first, so I'll write matrix O first, then plus sign, and then matrix A. In next step, I'll add the entries of matrix O to the corresponding entries of matrix A. And after addition, I have got this matrix, which is also equal to A. Hence prove that matrix O is called additive identity of matrix A. Now, after understanding all these concepts, you can easily do question number 4 and question number 5 by yourself. Here is question number 6 of exercise 1.3, and it has two parts. I'm doing its second part for you, that is 2A transpose minus 3B transpose. First of all, I have to find out the transpose of matrix A and transpose of matrix B. Let this is matrix A and here is its transpose. Now let this is matrix B and here is its transpose. According to the question statement, I have to write 2 first, then transpose of matrix A, then minus sign, then 3, and then transpose of matrix B. In next step, I have multiplied 2 with each and every entry of the matrix, then minus sign, and then I have multiplied 3 with each and every entry of the matrix. Now, in next step, I'll subtract the entries of first matrix to the corresponding entries of the second matrix. And after subtraction in steps, I have got this matrix. Now, do its first part by yourself. Here is question number 7 of exercise 1.3, which is very important. In this question, we have to find out the values of A and B. Here, I am rewriting this equation to solve. Now, first of all, I'll multiply 2 with each entry of the matrix, then plus sign, and then I'll multiply 3 with each entry of the matrix, then equal sign, and then I'll write above matrix as it is. Now in this step, I have to add the entries of the first matrix to the corresponding entries of the second matrix, then equal sign, and then above matrix as it is. Now after addition, I have got this matrix. In this matrix, the first entry is 7, the second entry is 8 plus 3b, the third entry is 18, and the fourth entry is 2a minus 12. Then equal sign, and then above matrix as it is. Now I am copying this equation here. As you can see that These two matrices are equal, so according to the condition, entries of first matrix should be equal to the entries of second matrix. So here first entry of first matrix is 7 and the first entry of the matrix on the other side of the equation is also 7. The second entry is 8 plus 3b, which is equal to 10, as 10 is second entry of the second matrix. So due to unknown value in it, I'll make it as 8 plus 3b is equal to 10 and give it a name, equation 1. Now see, third entry of left matrix is 18 and the third entry of second matrix is also 18. Now go for the fourth one, as fourth entry of left matrix is 2a minus 12 and the fourth entry of right matrix is 1. Here it becomes 2a minus 12 is equal to 1 and become equation 2. Now consider equation 1, that is 8 plus 3b is equal to 10. Bring 8 to the other side of the equation by changing its sign. 10 minus 8 is equal to 2. And by bringing 3 to the other side, I'll get the value of b, that is 2 by 3. Now consider equation 2, that is 2a minus 12 is equal to 1. Bring 12 to the other side by changing its sign. So 1 plus 12 is equal to 13. Now by bringing 2 to the other side, I have got the value of a, that is 13 by 2. So the value of a is 13 by 2 and the value of b is 2 by 3. Next topic is symmetric matrix. A square matrix is symmetric if it is equal to its transpose. As you know that square matrix is a matrix in which number of rows is equal to number of columns. For example, this is matrix M of order 3 by 3. So it's a square matrix. I'm going to take its transpose. Here is a reminder that interchanging of rows into columns or columns into rows is called transpose of that matrix. So here is transpose of matrix M and you can see that its transpose is equal to M. Thus M is symmetric matrix. Our next topic is skew symmetric matrix. A square matrix A is said to be skew symmetric if transpose of A is equal to negative A. For example, this is matrix A and the equation is transpose of A is equal to negative A. On left hand side, here is transpose of matrix A. On right hand side, according to the above condition, I have written negative sign first and then matrix A. Now, same matrix will bring down till the last step. And here, I am multiplying negative sign with each entry. Same matrix will bring down. Then on left side, we have negative of matrix A. You can see that transpose of matrix A is equal to negative A. So A is skew symmetric matrix. Here is question number 8 of exercise 1.3. It has 6 parts and I am doing part 3 and part 6 for you. Here is its third part, and according to the statement we have to prove that A plus A transpose is symmetric. So the condition is transpose of A plus A transpose should be equal to A plus A transpose. So first of all we have to find out the transpose of matrix A. Let this is matrix A and here is its transpose. Now I am taking left hand side, that is transpose of A plus A transpose. I'll solve brackets first. As A is written first, so I'll write matrix A first, then plus sign and then transpose of matrix A. Now I'll add the entries of first matrix to the corresponding entries of the second matrix, and after addition I have got this matrix. Now the transpose of A plus A transpose is here. Now I am taking right hand side, that is A plus A transpose. As A is written first, so I'll write A first, then plus sign and then transpose of matrix A. Now I'll add the entries of first matrix to the corresponding entries of the second matrix, and after addition I have got this matrix. You can see that left hand side is equal to right hand side, that is transpose of A plus A transpose is equal to A plus A transpose. As it satisfies the equation, thus A plus A transpose is symmetric matrix. Here is part 6 of question number 8, and according to the statement we have to prove that B minus B transpose is skew symmetric. So the condition is transpose of B minus B transpose should be equal to negative of B minus B transpose. So first of all I have to find out the transpose of matrix B. Let this is matrix B and here is its transpose. I am taking left hand side, that is transpose of B minus B transpose. I'll solve brackets first. As B is written first, so I'll write matrix B first, then negative sign and then transpose of matrix B. Now I'll subtract the entries of first matrix to the corresponding entries of the second matrix, and after subtraction I'll get this matrix. Now here is the transpose of B minus B transpose. Now I'm taking right hand side, that is negative of B minus B transpose. I'll solve brackets first. As B is written first, so I'll write B first, then negative sign and then transpose of matrix B. Now I'll subtract the entries of first matrix to the corresponding entries of the second matrix, and after subtraction I'll get this matrix. Now after taking negative sign common, I'll get this matrix. You can see that left hand side is equal to right hand side, that is transpose of B minus B transpose is equal to negative of B minus B transpose. As it satisfies the equation, thus B minus B transpose is skew symmetric. Now do rest of the parts by yourself. Students, this is all about exercise 1.3. Thank you very much.